Hey guys, welcome back to Probability and Statistics. I'm your TA Brittany, and today we're going to be going over exponential distributions. So let's recall our fundamental principles on what a PDF and a CDF is. PDF actually stands for a probability density function, and we actually went over this in a previous video, but just to do a quick recap, we can say that the probability density function, or our PDF, is equal to some little f of x, which can be equal to some function. And for this video, we're going to be talking about exponential distributions. So we can say that our little f of x is equal to actually the equation of lambda times our e, all to the power of a negative lambda times our random variable x. And so note here that we're doing the power of e to a negative value. So don't forget that negative sign there. And for CDF, our cumulative density function, which is our CDF, can be represented by a big f of x. And that's actually equal to the probability of our random variable x being less than or equal to some value x. And so if we recall the relationship between our PDF and CDF, we can basically derive our CDF function as also being equal to 1 minus e to the negative lambda times x. Oh yeah, and just a couple quick things about properties of exponential distributions. We can remember that they are memoryless. Also, just to be careful with your unit conversions, where x can be the distance between Poisson events. And lambda is the mean number of events for the interval. So when you're doing lambda times x, just make sure you're careful with your unit conversions there. Oh, and one last thing about lambda, don't forget that in a problem, if you're given the mean for an exponential distribution is equal to 1 over lambda. So you'll need to convert this value, if you're given the mean, from 1 over lambda. You'll need to convert mean into a value for lambda itself. So don't forget your conversions there as well. So another cool thing to note is the probability of having no counts within a certain interval. So what's the probability that within a certain interval, so within some interval from, let's say from 0 to 2 hours, we're going to have no counts of something. So how do we represent that in terms of probability? Well, this is the probability that within this interval, we're going to have some value of n being equal to 0. In other words, we have no counts within this interval. So this can actually be written as the probability of our big X, so our random variable x, being greater than or equal to a little x. In other words, all of our counts are going to be outside of this interval. And so the counts that we have within this interval are just 0. Well, we can rewrite this by saying that this is equal to the probability of x being greater than or equal to some value of little x. This is actually equal to, we can rewrite this by saying that this is actually equal to 1 minus a big f of x, since we're doing a reverse sign here than what we normally have. So we'd have to subtract our CDF value. So we can rewrite this by plugging in our big f of x value and just say that this is equal to 1 minus, and then some f of x. We know f of x is 1 minus e to the negative lambda times x. And then we can rewrite this further by canceling out values, 1 minus 1 plus e to the negative lambda times x. So we rewrite this and say e to the negative lambda times x. Other important things to note about an exponential distribution is that the mean, as we recall, this is our mu, is equal to 1 over lambda. We also know that our standard deviation is equal to 1 over lambda. And so if we're trying to find our variance, that'll be equal to our sigma squared, which is our standard deviation squared, which is equal to our standard deviation squared, which is just 1 over lambda squared. All right, and that's pretty much all for today. I hope that was a good review on exponential distributions. Let me know if you have any questions in the comments down below, and I will see you next time. Bye!